So I'm excited to be here. As a Sooner, it used to be that Sooners and Huskers would get together a lot, but we don't do that as much anymore now that you're in the Big Ten, so it's good to be here. Thanks for coming, taking a night out of your busy week to come in here and talk about modern scientific evidence for the existence of God, and that's what I want to talk about. I'm not going to talk about proof of God. I don't believe you can prove God from science. I don't think you can prove God, period. But if you were on a jury, I've sat on a few juries, you would be presented evidence. And then as a jury, you'd have to decide how strong the evidence is, what does the evidence point to. And that's what I want to talk about tonight. I want to present some scientific evidence, modern scientific evidence, for the existence of God. There was a time in history when a lot of famous scientists were men of belief. They believed there was a God. These were actually Christians. Isaac Newton, James Clerk Maxwell, Michael Faraday, and Blaise Pascal, names you may have heard of if you've had a physics or math class. And these people were both great men of science. We still study Newton's laws and Faraday's laws. And they were also people who were Christians, had a faith in God. But if you notice something about these pictures, they're not modern pictures. They're old pictures. They're black and white, or they're paintings. And we live in a very different world. We live in a world of space telescopes. This is the Large Hadron Collider where I do my work. This is a detector I work on called the Atlas detector, where we look at the debris from the collision of protons to understand the subatomic particles and what the universe is made at the most fundamental level. And you might ask, in this modern world that's so different from the world of those early scientists, is it still reasonable to believe in God? Or has modern science kind of made belief in God unnecessary or irrelevant? So tonight I want to talk about this question. What does science have to say about God and the place of humans in the universe? Now, sometimes the story of science and modern science is told like this. I've actually heard an astronomy professor at University of Oklahoma tell the story of science something like this. A long time ago, humans were naive. They thought that the Earth was the center of the universe, and they thought that God had something special, that God cared about humans. But then Copernicus came along, and Copernicus said that the Earth was no longer the center of the universe. The sun was the center of the solar system, and that seemed to demote humans from some central place. And then along came Isaac Newton, and Newton said that the universe is run by mechanistic laws, and that you really didn't need God to cause anything to happen in the universe, because the deterministic laws themselves cause the universe to work like a clock, and why do you need God if the clock is just running well? And then Charles Darwin came along and said that humans not only are not the center of the universe, but they're nothing special. They're just the product of time and random mutation and natural selection. And sometimes the story of science is told like that. But that story of science has a couple problems. The first problem is it's not even true. And let me give you one example of that. Here's what the picture of the universe looked like before Copernicus' time. This is from Dante's Divine Comedy. It does say that the Earth is the center of the universe and that the planets and sun all orbit around them. But what most people don't know is that the idea back then was the closer you got to the center of the universe, the worse things got. And in fact, in the very center of the universe, in the middle of the Earth, was hell itself. And the Earth was kind of like the garbage heap of the universe. And the garbage of the universe fell to the Earth. That's why everything fell to the Earth. And so when Copernicus came along and said the Earth is not the center of the solar system or the universe, instead it's one of these same things as the planets that orbit the sun, he actually elevated the place of the Earth. Because the planets were thought to somehow be perfect, and the Earth was somehow thought to be a garbage heap, imperfect. And so when Copernicus said we're not the center of the universe, that actually elevated humanity in the mindset of the people. It didn't demote humanity. But the biggest problem with this supposed story of science is it's all old. These are also old pictures. None of these have to do with modern science. And I want to talk about science that's been developed more recently, actually over the last 100 years or so. And I want to ask the question, what does modern science tell us about God and the place of humanity in the universe? And I want to look at three things tonight: the origin of the universe, the design of the universe, and something called the rare earth hypothesis. So let's start with the first one, the origin of the universe. Prior to about 1929, most scientists believed that the universe was eternal, that it had always existed, that it was probably infinite in size and infinite in time. And then Edwin Hubble came along, and he noticed that all the galaxies were expanding, were moving apart from the other galaxies. It's kind of like this model of the universe, which is the raisin bread model of the universe. And each of these raisins is a galaxy, and notice that as the raisin bread rises, the galaxies all get farther apart. Or the raisins, in this case, all get farther apart. Well, and that's what Hubble noticed. The galaxies in our universe were all getting farther apart. And what this implied is that the universe was expanding. Now, if the universe is expanding, you don't have to be a rocket scientist. I guess he was a rocket scientist. But you don't have to be a rocket scientist to run the film backwards and realize that the expansion had to have a beginning. So if the universe is expanding now, you can run the film backwards. The universe had a beginning. And so this expansion of the universe implies an origin. Now, scientists at the time understood that this expansion of the universe implied an origin, and it was not a very popular idea. Arthur Eddington wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." And so scientists were reluctant to accept this model of the universe that we now call the Big Bang, but the observational evidence became so overwhelming that they eventually accepted it. And there are three pieces of evidence that cause scientists to reluctantly accept this Big Bang origin of the universe. The first is the expansion of the universe. The second is what we call the temperature of the universe. And the third is the elements in the universe. So let me just briefly go through these. We've already talked about the expansion of the universe. This is a picture taken from what's called the Hubble Deep Field Telescope. And it's a little point in space. If you were to take your arm, hold your arm out at arm's length, I guess that makes sense, hold your hand out at arm's length and look through a little hole the size of a pinhole. At a point in space that we think there was nothing there, this is what you see. And each of those dots, with about two exceptions, are galaxies. Some of these galaxies are 13 billion years old. And the farther we look, the faster the galaxies are moving away from us. We see the expansion of the universe. That's the first evidence that the universe had a Big Bang origin. The second evidence is the temperature of the universe. If you were to take your oven and turn it on and get it really hot, and then turn the oven off and open up the door, that heat from the very hot oven would eventually dissipate throughout the whole room. Well, in the model of the Big Bang origin of the universe, the temperature of the universe at its origin was very hot and compressed into a much smaller space, like the heat in the oven. And although we're much past that original time, we should see the leftover heat, just like you'd see the leftover heat from the oven. And in 1964, two physicists, Penzias and Wilson, discovered this excess heat. It's called the cosmic background microwave radiation. And it's exactly what you would expect to see. It's a blueprint of what the universe looked like 380,000 years after the Big Bang. It should be almost uniform, because no matter where you look in the universe, it's more or less uniform. But it should be not quite perfectly uniform, or you wouldn't be able to form stars and galaxies. And when we compare what we see in the temperature in the universe to what we expect if the Big Bang was the origin of the universe, it's exactly correlates. So this is a picture of the whole sky. The different colors are slightly different temperatures, one part in a few 100,000 or something. And the slightly orange spots are slightly hotter, the blue spots are slightly cooler. This was taken by a satellite called the Planck satellite. But the point is that this is exactly what you would expect. I say 1 in 10,000. I think it's actually 1 in 100,000. But this is exactly what you would expect if the universe had a Big Bang origin. So the temperature of the universe looks exactly like the universe was at one time very dense and very hot. And then the elements in the universe are what you'd expect. About 3 minutes after the universe began, hydrogen and helium formed, and a little lithium. That's all that formed. The stuff that we're so familiar with, carbon and aluminum and silicon and iron, those did not form in the first 3 minutes. But helium and hydrogen did, and we should expect to see about 73% hydrogen in the universe and 26% helium, and it's exactly what we see. Again, the predictions are in agreement with the observations to about 1 part in 10,000. So these three observational ideas, or these three observational experiments, showed that the universe seemed to have an origin. And in retrospect, we probably should have expected that. In the early 20th century, Albert Einstein developed a theory of gravity called general relativity. And his theory actually predicted that the universe should be expanding as if it had an origin. But Einstein didn't like that idea. Even though the calculations, the math said the universe should be expanding, He knew what that implied. So he added something called a cosmological constant, a fudge factor, to the equations in order to get rid of the expansion of the universe. And when Hubble made his discovery that the universe was expanding, Einstein took away the fudge factor and said that was one of the biggest mistakes of his career in trying to get rid of the expansion of the universe. But in 1970s, George Ellis, Roger Penrose, and Stephen Hawking took Einstein's theory of general relativity, which implied that space was expanding, and they expanded it to include time. And what they saw is that the general theory of relativity also implied that not only space was expanding and had a beginning, but time itself had a beginning. And so we call this thing the Big Bang, but that's really a poor name for this, because a bang implies there's something there to explode. But really what the Big Bang is, it's the origin of everything we know in the universe. It's the beginning of space and time and matter and energy. It's like a creation event. Right? Now, that creates problems. Paul Gribben wrote, the biggest problem with the Big Bang theory of the origin of the universe is philosophical, perhaps even theological. What was there before the bang? Right? So if the universe had an origin, then the cause of the universe can't be part of the universe. It has to be what's called transcendent, not a physical part of the universe. So the Big Bang origin of the universe leads to this idea that the cause of the universe is transcendent, not a part of the universe. And this has certain theological implications. Robert Jastrow wrote about those theological implications. He says, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who have been sitting there for centuries. Right? So what has happened is science has kind of stumbled upon discoveries that are written in the Bible long ago. For instance, science has now discovered that the universe had a beginning. But the very first verse in the Bible declares the universe had a beginning. In the beginning, God created the heavens and the earth. Science has now learned that the stuff of this universe did not exist at one time. But the writer to the Hebrews wrote 2,000 years ago, we understand that the universe was formed at God's command so that what is seen was not made out of what was visible, that the stuff we see didn't come from the stuff we see. And finally, science has just learned within the last 30 years that this time seemed to have a beginning. And the New Testament is the only holy book in all the world that explicitly talks about a God who acts outside of time, before time began. And Paul wrote that grace was given us in Christ Jesus before the beginning of time, so that this transcendent being acts before time even began. So the origin of the universe points to a transcendent cause. That's the first scientific evidence for God. The second thing I want to talk about is the design in the universe. The design in the universe is sometimes called the cosmological anthropic principle or the anthropic principle. Probably the definitive book on this was written in 1986 by Frank Tipler and John Barrow. And in their book, they list over 100 parameters that must be fine-tuned to allow life to exist in the universe. It's as if you had a panel with 100 knobs, and if you twist any one of the knobs one way or the other, you would dial in a universe that is inhospitable to life. So I want to talk just about a few of those design parameters. I can't talk about all 100 because you'd all go to sleep or something. So let me talk about a few. The first is the amount of matter in the universe. So as the universe expands, all of the matter is attracted to all the other matter by gravity. It's like, having something expand with rubber bands between it, because that's a force of attraction. Well, if there's too much stuff in the universe begins to expand but immediately collapse again. And it only can live for a few 100 million years before it collapses because there's too much stuff. If there's too little stuff in the universe, it expands so fast that there's no ability to form galaxies or stars or people or anything. And shortly after the Big Bang, within the first trillionth of a trillionth of a trillionth of a second or something, if you had put in just one dime's worth of matter extra into the universe, you would not have a universe that's hospitable to life, or no universe at all. So this is really remarkable. The amount of matter is fine-tuned to the correct amount to 1 part in 10 to the 60th. Paul Davies writes this about that fine-tuning. To choose rho, the Greek symbol rho, which means the amount of matter in the universe, so close to the critical amount, fine-tuned to such stunning accuracy, is surely one of the great mysteries of cosmology. If the crucial ratio had been 10 to the minus 57th rather than less than 10 to the minus 60th, the universe would not even exist, having collapsed to oblivion after just a few million years. Now, we think we know why this occurs. Why is the matter density exactly right? It's something called cosmic inflation. At the very early part of the universe expanded at a super fast rate, and it actually forces the matter density to be what it needs to be to allow a universe like what we have. It's a remarkably efficient mechanism for creating a universe that has just the right parameters that we need. And we learn more about how these things happen all the time. This is our current understanding. So the first thing that's finely tuned for us to exist is the amount of matter in the universe. The second thing is the strength of the strong nuclear force. So this is what I actually study in my research. I've studied this for about 30 years. But a little bit of science lesson. You all know that we are made of atoms, and every atom is made up of nuclei, and every nucleus is made of neutrons or protons, and every neutron or proton is made of quarks. There are 3 quarks and a neutron and proton. And it's the strong nuclear force that binds quarks together in neutrons and protons, and eventually binds neutrons and protons together in the nucleus. It's the exact strength of the strong nuclear force that gives us the periodic table. If I was to make the strong nuclear force just 2%, or 2% stronger, then what would happen is I wouldn't have hydrogen in the periodic table. Helium would be the lightest element that's really stable. And that would create problems for life. For one thing, stars burn hydrogen. For another thing, water is H2O, includes hydrogen. There wouldn't be water. So if I just increase the strong nuclear force by about 2%, I have problems with life. If I decrease the strong nuclear force by about 5%, then the periodic table looks like this. There's only hydrogen. Right? That would make chemistry class really easy because, just have hydrogen. Actually, if you're in physics, you know that hydrogen atom itself is not real easy, but that's another story, all right? But again, you tweak this one way, you don't have life. You tweak it another way, you don't have life. Or you don't even have anything, right? The periodic table is gone. Okay? Another thing that is finely tuned is the carbon in our bodies. So where does the carbon in your bodies come from? In fact, all of life is based on carbon. It wasn't formed in the Big Bang. Only hydrogen and helium, lithium were formed. So where did the carbon come from that you and I are made of? Well, stars have a lifetime, like everything in the universe. They're born, they live for a while, they die. And one of the last things stars do as they die is they create carbon. In the last process as they die, they create carbon. So you and I are made of stardust. We're made of the burned out remains of old stars. And the process of making carbon as the stars die is very complex. It goes through a lot of things called nuclear resonance states. I once tried to explain nuclear resonance states in one of these talks. It was totally a disaster, so I no longer do that. But instead, I want to give you an analogy. So to create carbon in stars is kind of like making a Rube Goldberg machine. And here's one. In this machine, you fly a kite, which causes this string to open up this door to a cage, which allows moths to fly out of the cage, and they eat the coat, which lightens the coat. So therefore, the shoe falls on the switch, which turns the iron on, which burns the squirrel who runs up the tree and jumps into the basket, which raises this cage so the bird can sharpen the pencil. All right, so this is a pencil sharpener. And if anything goes wrong along the way, you don't sharpen the pencil. Well, this is what's going on in the process that creates carbon is like. If anything goes wrong along the way, you don't have carbon. And Owen Gingerich wrote this about the process. Had the resonance level in the carbon been 4% higher, there would be essentially no carbon. Had that level in the oxygen been only 0.5% higher, virtually all the carbon would have been converted to oxygen. Without that carbon abundance, neither you nor I would be here tonight. I was interested to read just a little over a year ago that some researchers had done more research into how these resonances are actually created and what would it take to tweak them. And what they learned is that neutrons and protons are made of quarks, we know that, but that the actual mass of the quarks inside the neutrons and protons plays a crucial role in creating these nuclear resonance states. And what this physicist wrote, there was a team of 3 people, 2 others from Germany, said, we find that more than a 2 or 3% change in the light quark mass would lead to problems with the abundance of either carbon or oxygen in the universe. So now I have a knob that tells me the mass of the up and down quarks, those are the light quarks inside the neutrons and protons, and if I turn that knob by 2 or 3%, there's no carbon, there's no life in the universe. Okay, so it's finely tuned. So there are a lot of things like this. I've listed a few. There are at least 100 similarly fine-tuned parameters, and you might ask, what do scientists say about such fine-tuning? So scientists say things like this: such properties seem to run through the fabric of the natural world like a happy thread of coincidences. But there are so many odd coincidences essential to life that some explanation seems required to account for them. Gribben and Rees wrestle with this problem. They say if we modify the value of one of the fundamental constants, something invariably goes wrong, leading to a universe that is inhospitable to life as we know it. When we adjust a second constant and attempt to fix the problems, the result generally is to create 3 new problems for every one that we solve. The conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. And finally, Paul Davies writes about this fine-tuning. There's, for me, powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. Now, these scientists I'm quoting are not theists. They're either agnostic or atheists. But they see these design parameters, and they make statements like this that could easily be interpreted in a theistic worldview. So I've talked about the origin of the universe. I've talked about the design in the universe. Finally, I want to talk about this thing called the rare earth. So if you're a fan of science fiction, then you know that Star Wars or Star Trek or something, then you know that throughout the universe there's lots of beings like us that are more, some have green skin and some have bigger ears and some have weird nose ridges or something, but more or less they're scattered throughout the universe. And we can ask the question, what would it really take to find a planet like the Earth that you might be able to find some beings like us? But let's not even make it beings like us. Let's say, what would it take to find a planet like the Earth that could have any form of complex life, higher life forms? Now, what do I mean by that? Anything more complex than bacteria. So even a virus, which is more complex than bacteria. Bacteria can thrive under any conditions. We know that. We find bacteria at the hottest vents under the ocean, at the coldest places. But let's ask, what does it take to create a planet that can support life anything more complex than bacteria? So first of all, let's think about the galaxy. This is what our galaxy, the Milky Way, would look like if you could get very far from it. It's called a spiral galaxy. These things that look like spirals are stars. There are about 200 billion stars in our galaxy. And only about 10% of the galaxies in the universe are spiral galaxies. The rest are called elliptical galaxies or irregular galaxies. Only in spiral galaxies could you have higher life forms. The radiation in other kinds of galaxies and the rate of star formation is such that it would preclude higher life forms. But yet you can't live anywhere in a spiral galaxy. If you live too close to the middle, there's too much radiation. At the very center is a gigantic black hole, supermassive black hole. That would be a bad place to live. If you live too far from the center, then there's not enough stuff in the galaxy to create planets like the Earth that are rocky. So you have to live in this part from about 1/3 of the way to 2/3 of the way, which is called the galactic habitable zone. And of course, our sun happens to be in this perfect spot in the right galaxy. You have to have a star that's kind of like our sun. Our sun is called a Class G star. Class G stars are the only stars that burn stably enough and long enough to support planets like the Earth. There are other factors about our star that make it very unique. One is that it's called a bachelor star. More than half the stars in the universe are binary stars. They're 2 stars that circle each other. But binary stars can't support stable circular orbits that could have planets like the Earth. So you have to have a bachelor star. You also have to have something called a 3rd generation star. Remember I said that stars have a lifetime. Well, the first stars ever made after the Big Bang only had hydrogen and helium. There was nothing that could support life, like carbon or oxygen. Those first generation stars died. From the debris of those first generation stars, a 2nd generation of stars formed. There are still some 2nd generation stars around, but many of those lived and died, and from their debris, a 3rd generation of stars formed. Our sun is a 3rd generation star. And 3rd generation stars are the first generation of stars that have enough heavy elements like iron, oxygen, silicon, carbon to create rocky planets like the Earth and life. So if you read Carl Sagan's book Contact or saw the movie Contact, the question was brought up, or the statement was made, if the universe is so big, then there's a lot of wasted space if you don't have other planets with life. So there must be other planets with life. Well, I don't know if there's other planets with life or not, but I want to address the issue of the lot of empty space. So let's say we started with a Big Bang and we wanted to create one planet like the Earth that could support life. Again, I don't know, there may be billions and billions. We'll talk about that later. But let's say you wanted to make just one planet like the Earth. Well, it takes 3 generations of stars, which takes about 9 billion years, and then the planet around the star has to cool and stabilize, which takes another 4 billion years. So the shortest amount of time it takes to create a single planet that can support life is about 14 billion years, exactly the age of our universe. Now, as the universe ages, it gets bigger. So the younger universe is smaller, the older universe is bigger. So suppose you wanted to make one planet like the Earth. Since this is the youngest universe you could have to make one planet like the Earth, because you need 3 generations of stars, it's also the smallest universe you could have. So as gigantic as this universe is, it's the smallest universe you could have and have a single planet like the Earth that could support life. The question is not, why is the universe so big? The real question is, why is the universe so small? It's as if it was set up for us to be here as soon as we could in the smallest universe we could be. There's no wasted space. You couldn't have a smaller universe and have a single planet that could support life. It's quite remarkable. And then our planet Earth, there's so many parameters about the Earth that are required for life. Its size, its specific gravity, its rate of rotation, the amount of water it has, even tectonic activity. It's been shown that higher life forms require tectonic activity or they can't exist. Now, I used to live in California. I lived there for 25 years. We know what tectonic activity does in California, right? And you might think that's a bad thing, but it's not. Tectonic activity is actually required for higher life forms to exist. There are lots of other parameters. We have a single large moon that stabilizes the tilt of the Earth. We have a single planet, Jupiter, that's almost in its perfect circular orbit, but is so massive that it acts like a vacuum cleaner. Its gravity sucks in asteroids and comets that could come towards the Earth and destroy life on the Earth. So we really live in the right place in the universe with the right solar system and the right sun and the right planet and the right galaxy to support life. In their book, Rare Earth, Peter Ward and Donald Brownlee write, if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that is the Earth, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. Right? So this planet seems to be rare. The universe seems to be fine-tuned. And scientists do look at this and they wonder about it. They ask questions. Fred Hoyle says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Alan Sandage writes, I find it quite improbable that such order came out of chaos. There has to be some organizing principle. God to me is a mystery, but is the explanation for the miracle of existence why there's something instead of nothing. Alan Sandage was an agnostic scientist who looked at this kind of evidence and changed his mind and became a Christian based on the design he saw in the universe. So this begs a question. With all this improbability, this design, how could such a universe exist? And I want to give you some possibilities for how we could have such an improbable universe. Let's first go back to the definitive book on this principle, the Anthropic Cosmical Principle by Baron Tipler. Now, Baron Tipler believed that the universe is so well designed that it has to have an intelligence behind it. It could not have just happened. So there has to be some intelligence behind it. Baron Tipler also don't believe in God, and they go through a bunch of arguments to argue that there's no other intelligent life in the universe, only humans. So I pose the problem that they have, or the question they raise. If the universe requires intelligence to create it, and there's no God, and humans are the only intelligence in the universe, who creates the universe? Right? Well, Baron Tipler's idea is that humans will continue to evolve till they become like godlike beings, and that these godlike being humans in the future will reach back in time and create the universe for themselves. Okay? So this is my picture of what that looks like. All right? Okay. Now, that's not the only option. There are other options. A lot of physicists believe that there's an infinite number of universes, or a near infinite number. Sometimes the number 10 to the 500 is thrown around. So if there's a bunch of universes out there, almost all of them can't support life, but maybe one can. And maybe we happen to be in just the right one. That's another option. We'll talk a little bit about that in the future in a few more slides. Here's another option, that there really is a transcendent, intelligent designer and creator. And those are really about your only options to try to explain this universe, the fine-tuning of it. And you can pick which one you think is most probable. We'll talk a little bit more about those. So let me kind of review what I've talked about so far. First, I said that the universe seems to have an origin. The first evidence for that was in 1930. We still continue to study the cosmic background radiation and understand the origin. But that implies that the universe had a transcendent origin. The second thing I discussed was the anthropic principle. The fact that the universe appears designed for humans, and that was first developed in the 1960s. There's still work going on. The thing I read about the quark mass was done in 2013, so there's still work being done on this. And the rare earth hypothesis was first developed in the 1990s, that the habitable Earth seems rare, if not unique. Well, you may ask, are there anything more recent than this? I mean, this stuff is, even though it's modern in some sense, science moves along quickly. Has anything new been developed to challenge this evidence for God? And of course, people are writing a lot about these questions. Lawrence Krauss wrote a book called A Universe from Nothing. In fact, I understand Lawrence Krauss is at Nebraska Wesleyan University tonight, talking about a universe that he says comes from nothing. He's a professor from Arizona State University. Stephen Hawking wrote a book called The Grand Design about 5 years ago now. And I want to talk a little bit about this book, because I want to ask the question, what is the best alternatives to these ideas? If you don't believe in God, what are the best alternatives to these ideas? Stephen Hawking's a pretty smart guy, so he may give us the best alternatives to these ideas. And so I want to talk about what he discusses in The Grand Design. When I read this book, the first thing I noticed was that there are 3 questions that they ask in the book. Why is there something rather than nothing? This is in the first chapter. Why do we exist? And why this particular set of laws and not some other? And as I read those 3 questions, I thought that's exactly the 3 points that I have been talking about in talks like this for quite a while now. Why is there something rather than nothing? That's the origin of the universe. Why do we exist? That's in part because of the planet we're on, the rare earth. And why this particular set of laws and not some other? And that's the anthropic principle. And the reason that Stephen Hawking wants to address this is because he's been hearing people like myself say that these are evidences for God for 20 years, and he wants to try to say they're not. So he's going to address these issues. So if you don't believe in God, what's the best that one of the smartest people in the world can offer as an alternative? And that's what I want to talk about. That's why I'm going to talk about this book a little bit, because it's the best alternative if you don't believe in God. Right? What about the rare earth? Well, here's his alternative. There are lots of planets, so one must be suitable for life. There are lots of planets. We found over 1,000 planets outside our solar system. In fact, I believe there are probably a trillion or more planets out there. Okay? But this is really poor science, because Stephen Hawking hasn't asked the more difficult question. What is an Earth-like planet, and what conditions are necessary for an Earth-like planet? It's just one thing to say there are lots of planets, so one must be suitable for life. It's another thing to actually think about that for a second. So when you read in the paper, you'll often hear in the paper that scientists have found another Earth-like planet. To scientists, that means one of 3 things. It means either the planet is rocky. Well, Venus is rocky, but it's not really Earth-like, but that's what they mean. Or it's in an orbit that might have liquid water. Well, our moon is in an orbit that might have liquid water. That doesn't mean it's Earth-like. Or that it's about the same size as the Earth. Again, Venus is about the same size as the Earth. So it means only one of those three things. When you read, scientists have found an Earth-like planet, it means either it's in the right orbit for water, it's the right size, or it's rocky. But those things aren't really what you picture when you think of an Earth-like planet. You think of one that people could live in. Well, we've already talked about some of the things that are required for a real Earth-like planet, a planet that can support life more complex than a bacteria. It's got to be in the right galaxy. That's a 10% probability. The star has to be the right distance from the galactic center. That's 20% probability. You have to have things like the right star mass and age. You have to have tectonic activity. We don't really know the probability for that, so we take a guess, 5%. We know that none of the other planets in our solar system have tectonic activity, so it's probably not a bad guess. So you kind of do your best estimate of what it would take to find a planet like the Earth. This is a partial list. Here's the complete list, all right? Okay. There are at least 322 parameters that have been defined that are required to have an Earth-like planet. And when you do the math, including things called dependence or correlation, you get a probability of 10 to the minus 304th for finding a planet like the Earth by chance. Of course, there are a lot of planets, at least 10 to the 22, but still finding one like the Earth is a probability of about 10 to the minus 282. Now, in science, we have an official term for a number this small. We say it's not going to happen, okay? That's the official term, right? So when Stephen Hawking says there's lots of planets, there must be one, it's really sloppy thinking. Because you can do a back-of-the-envelope calculation and say, even with lots of planets, the probability of finding one that can support life is near zero. So it's really a poor answer. So what about the anthropic principle? What's Stephen Hawking's response to that? Well, it's basically the same idea. There must be a near infinite number of universes. A theory called M theory or string theory would allow for that. And that must be the reason. Is there any scientific evidence for M theory being true? Absolutely none. I would love M theory to be true. It's an awesome theory. I'm actually looking for evidence of it in some of the experiments I'm doing. But it's not science. It's just blind faith. Hawking doesn't like the idea that this universe seems designed, so his proposal is that there must be an infinite number of universes. But even if M theory were true, we don't know what the actual implications would be. We'd have to do the hard work. M theory is a theory without the hard mathematics actually done. We'd have to do the hard work and see what the real implications are. Would it really imply a near infinite number of universes? So this is, again, poor science. There's no observations that it's true. And even if it is true, until you do the hard mathematical work, you don't know what it really implies. And other people realize that. John Horgan wrote this about the book, The Grand Design, and about M theory. M theory, theorists now realize, comes in almost infinite number of versions, which predict an almost infinite number of possible universes. Of course, a theory that predicts everything really doesn't predict anything, right? And that's the real point. This is not science. It doesn't predict anything. It's kind of, again, blind hope that maybe there's a way out of the anthropic principle, because the anthropic principle seems to point to God. I kind of wrote this as I was reading the book, or thought this. It's unfortunate that a scientist of Hawking's caliber would call M theory science and invoke some of its possible predictions as evidence for or against anything. It's not science, because science is always based on experimental results. And this is just speculation and conjecture and hope that there might be a way out of the anthropic principle. So what's Hawking's answer to the origin of the universe? The third thing. Well, this is not a new answer for him. He came up with this proposal in his book, A Brief History of Time. I think this was the most bought book that was never read or something in the history of books. But he says that the universe may not have a real beginning. And again, there's a lot of problems with this. First of all, this no boundary condition requires the laws of physics to operate even before the universe. It still requires a beginning, and I could talk to you about the details of why that's true. There's no evidence for it. And again, real scientific observations do point to the universe having a beginning. That's why scientists don't like the Big Bang. There was an article in the newspaper not long ago that scientists again question whether the Big Bang happened. They're not really questioning whether the Big Bang happened if you read the paper in detail. What they're questioning is what happened in that first 10 to the minus 36 seconds. Was there a true beginning or not a true beginning? Because scientists don't like the idea that there was a true beginning, and they're coming up with the wildest theories to get rid of that true beginning. We know that from 10 to the minus 36 seconds till now, it looks like it had a beginning. So it's kind of the atheism of the gaps. You've heard of the God of the gaps? Since everything from 10 to the minus 36 seconds until now looks like the universe had a beginning and a designer, maybe we can find something in the first 10 to the minus 36 seconds that precludes that conclusion. And that's what the paper was really speculating about, those first 10 to the minus 36 seconds and whether or not there was a real beginning or not. But the real observations all point to a beginning. That's why the Big Bang is such a problem. But beyond that, what was really disappointing about Stephen Hawking's book, one of the smartest people on the earth, is that in a logic class, a science class, philosophy class, or religion class, you would give this book a failing grade. So if you've had sophomore logic, I want to pose this to you. Hawking poses the question in the book, are there any exceptions to the laws of physics? In other words, are miracles possible? And here's his answer. Okay? The modern scientist's answer to the question, are miracles possible, is a scientific law is not a scientific law if it holds only when some supernatural being decides not to intervene. Okay? Anybody have logic, can see the flaw in this? This is a logical flaw. It's called begging the question. It's basically stating an answer that you want without any reasons behind it. If you wrote this in a paper in a logic class, you'd get a big fat F because it's not an answer at all. And it was really disappointing that this is the best answer Stephen Hawking can give because he does not believe in God. Right? And in fact, I wasn't the only one that read this book and was extremely disappointed. Dwight Garner in the New York Times wrote, the real news about this book, The Grand Design, is how disappointingly tinny and inelegant it is. So if you see these three things, the origin of the universe, the design of the universe, and the rare earth, and you want to come up with an alternative other than God, you come up with something that's disappointingly tinny and inelegant. That's your options. So how strong is the scientific evidence for God? Those who best understand the evidence but don't believe in God instead come up with ideas like this. Humans evolved to be godlike beings who reach back in time and create the universe for themselves. Or possibly the laws of physics must precede this universe, must include M theory, which can predict anything, which caused the creation of 10 to 500 or more universes, despite any lack of confirming experimental evidence. So this isn't really science. These aren't scientific in any way. These are inelegant, naturalistic leaps of blind faith in order to avoid the conclusion that there is a God. And that's what you're left with from this evidence if you don't believe in God. So then you can ask the bigger question. So what if the universe is designed? Who cares? What does that mean? And Paul Davies wrote a very interesting quote to me. If physics is the product of design, the universe must have a purpose. And the evidence of modern physics suggests strongly to me that the purpose includes us. Here's a person who doesn't believe in God, but looks at the evidence from modern physics and comes to the conclusion that the universe seems to have a purpose, and the evidence of modern physics suggests that that purpose includes humanity. Again, I have to marvel at how close this is to statements made in the Bible. Here's what modern science tells us, that the universe may have a purpose and the purpose includes us. Here's what the Bible says, that humans have a purpose. King David wrote, when I consider the heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you are mindful of him, and the son of man that you care for him? King David asked the same question when he looked at the universe. How is it that the universe has a purpose and that purpose includes man? And then Zephaniah, the prophet, wrote, God takes great delight in you as humans. He will quiet you with his love. He will rejoice over you. That the universe has a purpose, and that purpose includes humanity. Now, there are scientists, like I said, who look at this evidence, and because of it, they change from not believing God to, in this case, becoming Christians. That was the case for Alan Sandage. He wrote, it was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence. And George Greenstein writes, as we survey all the evidence, this thought insistently arises that some supernatural agency, or rather agency with a capital A, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Now, as I said, I don't believe you can, quote, prove God from science, but this is a strong statement. Stumbled upon this kind of proof. There's different levels of proof. There's the kind of proof you have to have in a courtroom, which is beyond a reasonable doubt. There's the kind of mathematical proof, which is beyond any doubt. And when I say you can't prove God, I mean the second kind, beyond any doubt. I think it's proven beyond a reasonable doubt. In that sense, I would agree with him. This evidence is strong and powerful. So where we start with, does modern science take away the need for any God? We actually, by looking at modern science, comes to quite a different conclusion. And that conclusion is that these discoveries of modern science give abundant evidence for the existence of a transcendent, intelligent designer, not only who created the universe, but has a purpose for humanity. And I think that's the best explanation for what we see when we look into the universe.